Hello guys, welcome back to our channel. And welcome to today's video, Chain of Thought Prompting versus Tree of Thought, the battle of AI reasoning paradigms. In the evolving world of artificial intelligence, reasoning plays a pivotal role. We often talk about AI's ability to generate answers, but how does it think? Enter two powerful methods, Chain of Thought, CoT, and Tree of Thought, ToT, prompting. These approaches are changing how large language models like GPT and Palm reason through complex problems. In this video, we'll take a deep dive into both methods, explore their strengths, limitations, and most importantly, when to use which. Stick with us to the end, because by the time we're done, you'll have a clear grasp of how CoT and ToT can revolutionize reasoning in AI. Before diving into the specifics, let's set the stage. What is reasoning in AI? Reasoning in AI refers to the model's ability to solve problems that require multiple logical steps, not just a quick lookup or fact recall. Examples include solving math problems, coding challenges, riddles, and making strategic decisions. Early models struggled with reasoning because they attempted to answer in a single forward pass. But then, prompting strategies like Chain of Thought emerged, and later Tree of Thought, changing everything. Now let's understand the topic, Chain of Thought prompting. Chain of Thought prompting is a technique used in prompting large language models, LLMs, to improve their reasoning capabilities. Instead of asking a model to generate a final answer immediately, you prompt it to think, step by step, mirroring how humans solve problems by breaking them down. And key features of CoT prompting. Step-by-step reasoning transparency, better performance on complex tasks, few-shot learning friendly. There are three common approaches in prompting strategy. Manual CoT prompting, few-shot CoT, zero-shot CoT. Advantages of CoT: improves accuracy, makes reasoning explainable, works on pre-trained LLMs. Limitations of CoT: linear reasoning only, cannot explore alternatives, can still hallucinate. If the initial steps are flawed, the answer will be 2. Now go ahead with Tree of Thought prompting. Tree of Thought, ToT. Prompting is an advanced reasoning framework designed to improve the problem-solving capabilities of large language models, LLMs. Core components of ToT: thoughts, states, tree, search and evaluation. How ToT prompting works. Number 1, problem initialization. Define the problem or goal state. After that, thought generation. The model generates multiple candidate thoughts, possible next steps. Next one, state expansion. Each thought leads to a new state, which becomes a node in the reasoning tree. Following that, search. The tree expands as the model explores multiple reasoning paths. Then after, evaluation. The model uses scoring, feedback, or heuristics to assess the quality of each path. Lastly, selection. The best path is chosen as the final reasoning chain or solution. Use cases of Tree of Thought, strategic planning, game playing, creative writing, scientific hypotheses, code generation. Advantages of ToT, superior reasoning, error tolerance, human-like deliberation. Limitations of ToT, higher computational cost, prompt complexity, slower inference. CoT versus ToT, key differences. Now, let's put CoT and ToT side by side. First, structure. CoT is linear, ToT is branching. Second, exploration. CoT follows one path, ToT explores multiple paths. Third, efficiency. CoT is fast and lightweight, ToT is slower but smarter. Fourth, use cases. CoT is great for straightforward reasoning tasks. ToT excels in planning, puzzle solving, and ambiguity. Applications of Chain of Thought, CoT, prompting education and tutoring, financial reasoning and calculations, customer support automation, legal and policy reasoning, scientific research support applications of tree of thought, ToT, prompting, game playing and puzzle solving, strategic planning, creative writing and storytelling, coding and algorithm design, scientific discovery and hypothesis testing, negotiation and decision-making, multi-agent collaboration. Both chain of thought and tree of thought prompting techniques represent significant steps in making AI more human-like in reasoning. CoT is fast, transparent, and useful in structured, linear thinking. ToT is powerful for high-stakes, creative, or exploratory decision-making. Now move on to limitations and challenges. Here are the limitations of tree of thought, ToT. Prompting. First one, linear thinking restriction. CoT follows a single linear path of reasoning from start to end. Challenge. If the model takes a wrong turn early in the chain, it will continue down an incorrect path without correction. Impact. Limited ability to explore alternative solutions or backtrack. Second one, no path evaluation. CoT doesn't evaluate its own reasoning or compare paths. Challenge. There's no built-in mechanism for error detection or correction. Impact. Incorrect answers may appear confident but are fundamentally flawed. Third one, vulnerability to prompt errors. CoT relies heavily on how the prompt is framed. Challenge. Poorly designed prompts may lead to logically invalid or verbose outputs. Impact. Requires significant prompt engineering expertise. Fourth one, cognitive load on the model. The model must remember and build upon previous steps. Challenge. In long reasoning chains, LLMs may hallucinate or lose context. Impact. May lead to incoherence or logical jumps. Fifth one, task-specific effectiveness. CoT is effective for arithmetic, logic, or basic planning. Challenge. Fails in tasks requiring exploration of multiple possibilities. Impact. Less suited for strategic or creative tasks. Next, limitations of tree of thought, ToT, prompting. Initial one, high computational cost. ToT expands reasoning into a tree with multiple branches. Unchallenge. Each branch requires model inference and memory storage. Impact. Resource-intensive and slower inference time compared to CoT. Secondly, complex implementation. ToT relies on recursive generation, evaluation, and selection mechanisms. Challenge. Requires building and managing a reasoning tree with states, evaluations, and pruning. Impact. Harder to implement in real-time or production systems. Thirdly, prompting and evaluation complexity. ToT needs thoughtful prompts, not just to generate thoughts, but also to evaluate and compare them. Challenge. Designing these prompts can be unintuitive or domain-specific. Impact. Demands deeper prompt engineering expertise and domain knowledge. Fourthly, slower response time. The model must simulate, evaluate, and choose among many paths. Challenge. Increases response latency. Impact. Not ideal for time-sensitive applications like live chat or voice assistants. Fifthly, evaluation metrics are imperfect. Models often rely on heuristic scoring, voting, or user-defined rules to evaluate thought branches. Challenge. These evaluations may not accurately reflect real-world utility or correctness. Impact. AI may still select suboptimal or biased reasoning paths. Sixthly, cognitive overhead for users. Outputs from ToT can be complex and multi-branch. Challenge. May overwhelm users or be difficult to interpret. Impact. Limits usability in end-user-facing applications unless simplified. Additional challenges in real-world adoption. Integration into applications, performance instability, lack of true understanding. Further topic, the future of AI reasoning. We may see hybrid models that blend CoT and ToT with tools like retrieval, search engines, or APIs. There's also growing interest in meta-reasoning, AI that can reason about how it reasons. And these advances may pave the way toward artificial general intelligence, AGI. As models grow in scale and intelligence, reasoning methods like CoT and ToT will be key to unlocking their true potential. Lastly comes to the conclusion. To wrap up, chain of thought and tree of thought prompting represent two major milestones in teaching AI to think better. And ToT simplifies reasoning into clear, linear steps. And ToT expands on this by allowing AI to explore, backtrack, and choose the best path. Both methods have their place. The best prompting strategy depends on the task, the complexity, and the computational budget. As we stand on the edge of a reasoning revolution in AI, understanding CoT and ToT is essential. If you found this video insightful, don't forget to like, share, and subscribe for more updates on AI and technology.